Okay, good afternoon once again and welcome to today's QT class. Let's get started right away. So in the last class, I did advise that it's best you go and review what has been considered in the two classes you have had thus far. This is to help you understand the foundations on which you're going to be building on. So I want to believe every one of us in this class have done that because we are moving on. We're going to be moving at a great speed now as we have a whole lot of things to cover going forward. All right, so today we want to start with annuity. Okay, I hope you have your CIS manual open somewhere because I'm going to be moving from here to a lecture note where I need to type as the case depends. All right, so so let's get started. Now, when we say an annuity simply means okay, so let me put it this way. Where's my writing? Yeah. So you have fixed payment. When you say something is an annuity, what does it mean? You have a time span. All right. And then at intervals in that time span, at regular intervals, you are paying a particular sum of money, okay, at regular intervals till the end of that definite period. That is what you call an annuity. Now, notice that this is like now, all right? Then at the end of the first period, you pay. At the end of the second period, you pay. That is called an annuity. So long it is the fixed equal installments for a fixed period of time, you call it an annuity. Now, in this case, the payment started at the end of the first period. See, I put my 5 here at the end of the first period. Now, if the payment had started at the beginning of that period, it is called annuity due. These are the terms I need you to be mindful of. Are you with me? So long the first payment comes at the end of the period, it is an annuity or ordinary annuity. If it comes at the beginning of that period, it is called annuity due. Now, both ordinary annuity and annuity due are for fixed period of time. But if the payment continues into perpetuity or eternity, let's put it that way, forever, then we call it a perpetuity. So these three concepts, we're going to be looking at them in light of the concept of financial maths today. All right, so can we have a volunteer read for us as is our usual practice? Let's have somebody read for us quickly from here. What is an annuity? Let's go. Anybody?
Okay. Annuity. Annuity refers to a series of fixed cash flows occurring over time. The most common payment frequencies are monthly, quarterly, and yearly. There are basically two types of annuity in finance: ordinary annuity and annuity due. Should I continue? Okay. Ordinary
Please
annuity.
do. Just keep reading. Yeah.
Ordinary annuity payments are required at the end of each period. For example, straight bonds usually paid fixed coupons at the end of each 6 months until the lifetime of the bond. Dividends are typically deducted from the firm's profits and paid at the end of the financial year. Cash flows on amortized loans usually occur at the end of each month. Then the formula. Should I? Okay. Formula PV equals to.
No. Thank you. Thank you. Let me take it off from here.
Okay,
Thank
okay.
you. Thank you so very much. All right, so now we know the difference between ordinary annuity, first payment at the end of the period, and annuity due, first payment at the beginning of the period. Please take note of this. Now, we've been giving examples of such. Now, present value of ordinary annuity, you have your formula here. Now, I don't want you cramming formulas. I would rather that you use one formula to deduce several other formulae that you might require. Okay, it's just like in simple interest. You see, simple interest is what? PRT over 100. Are we good? Hello, can I get a feedback? I hope you can still hear me.
Please go ahead, sir.
All right. I need to keep asking so as to be sure the network is on. So when I do ask like that, just respond if you can, please. So I don't keep talking to myself over and over again. So given this simple interest formula, or let's just start this I alone. Okay. How will you derive your time? Anybody help us? What is the formula for time from here? Multiply 100 by I, you get 100I. Divide that by what? PR. Okay. With your knowledge of change of subject or formula, you should be able to deduce this. How will you get your rate? The same principle. Multiply 100 by I, or you cross multiply. Then you divide this by what now? PT. How will you get your principal? The same principle. 100I divided by, in this case, RT. Now, you could have learned 4 formulas you would have learned 4 formulae related to simple interest, but you could have just stuck with this and be able to derive these remaining 3. I think the second approach is better. All right, so I don't know if I'm going to be able to wipe off. Yeah, I'm not. This thing has hidden my, but it's fine. Let's just go on. Can I wipe off? I don't have an eraser here. Okay, so why am I bringing this up? Can somebody please remind me of the formula for present value, ordinary present value? Let's go, and future value. Anybody who's helping us out? How do you get your present value? Somebody?
PV.
Yeah, PV is what?
PV is equal to FV all over open brackets 1 plus R close brackets.
Okay, so I don't want to use the over. How else can I express it? I don't want to use the over. How else can I express it?
You can raise to power minus.
Good. Minus n. That will be PV into, sorry, FV into 1 plus R raised to power minus n. By now, we should be familiar with this formula, right? And then what is it? Future value, on the other hand, will be PV into 1 plus R raised to power n. Are we all in agreement with this?
Yes, please.
Good. Now, why am I bringing this up? This can help you to know what to do when it gets to annuity. How is that so? First, you have been able to identify what an annuity is. Equal payments over a fixed period of time. If it comes at the end of the first period, ordinary annuity. If it comes at the beginning of the first period, annuity due. Right? Now, how do you know the formula for present value of ordinary annuity? First, the payments that will be coming up. You will be told that this fixed sum will be paid over given installments. This is where the issue lies, this bracket bit, and that is why I have referred back to this. Now, for present value, just remember that in your formula for calculating present value, there's always a raised to power minus n. There's always a what? Raised to power minus n. Because of that, let that be the clue. Let that be the trigger that leads you into differentiating these 2 formulas. So you go for present value of ordinary annuity, you have your A. I'm going to write this here. The same way you have it for the future value. Okay. Now, both of them will have a divided by R, the same R. These are the similarities. Now, what is the difference? Because in the formula for present value, you have a minus n. Let that be the trigger. Because of that minus n, you should know that you're going to have a negative 1 plus R to the power of n, negative n rather. Because of this minus n, now it's like you're just picking everything here and putting it here, then you put a minus in its front, 1 minus what you have here. Now, For future value, look at your basic future value formula. There is no n. Because there is no n, everything here comes before the -1 in the same formula. 1 plus r to the power of n minus 1. Are you with me? Why am I putting it this way? This is an easier method than you having to cram about 6 formulae. You're going to come across about 2 or 3 more. Okay? But if you know how to go by this little logic, you know how to derive all this without stressing yourself much. Again, you take it from your basic present value formula. 1 plus r raised to the power minus n. Because of the minus, you know all of this would be at this end here. 1 minus all of that, this, divided by the same r. For the future value, you look at your basic future value formula, there's no minus, it is starting. All of that minus 1 over the same r. Close your bracket, where A is your cash flow per period. Is this clear to us, please? Is it slightly clear? Do you have an idea?
Yes.
It is, but the logic.
Okay.
It is,
Okay.
but the
So
logic.
please stick by that logic. Otherwise, you might need to go and learn 6 formulae altogether. So let's move on and see how this applies. We have an example here. Can we have somebody read this example for us before I move to the next page? And again, I hope these questions are opened on your phone or elsewhere, because I'll be moving to a blank page now. Let's go. A volunteer.
Suppose you are considering purchasing a financial asset that promises to pay 1 million naira per year for the next 10 years, with first payment 1 year from now. The required rate of return is 12% per annum. How much should you pay for this asset?
All right. Now, from the way the question has been structured, you should be able to determine if this is an ordinary annuity or an annuity due, if it is asking you for the future value or the present value. How much should you pay for the asset? What does that tell you? Any volunteer? Is this future value or present value? How much should you pay?
Present value.
This is the present value.
Good. Now, is it an ordinary present value, basic present value question, or an annuity present value question? Let's investigate or inspect the question together. Suppose you are considering purchasing a financial asset that promises to pay 1 million per year for the next 10 years. What does that tell you? 1 million per year, instrumental payments for the next 10 years, fixed period. Can you see it now? What we do up here? Okay, so those are the clues that will help you understand. Now, one more thing. Okay, were we told with the first payment 1 year from now? 1 year from now, that is the end of the first period. So based on all this information, what can we decipher? This is an ordinary annuity question. I hope that is clear. Feedback. Is that clear, please?
Yes, sir. Yes, sir. Yes, sir. They are
All right, so
paying at
now
the end
that,
of the year.
good. Now that is clear, let's move to our worksheet and we solve this question there. So the question is asking us for what? Present value of ordinary annuity. Let me just start that OA, present value of ordinary annuity. How do I remember my formula? I know that for an annuity, I'm expecting a fixed amount. Some people call it PMT. It is fine. And I know that I'm going to multiply that by something in a bracket. Okay, and that something in the bracket has a denominator of R, the given interest rate. And this is the part that gets confusing. Is it 1 minus whatever or whatever minus 1? I quickly ask myself, how do I express my present value formula? I go present value is future value into 1 plus R raised to power negative n. Because of the negative n here, I get my trigger. So I know that it's going to be minus everything in bracket from that formula. Then I know it is 1 coming before it. This is how I get my present value of ordinary annuity formula. Okay, so from the question, what is the amount? I am getting 1 million every year. Please get your calculators handy. All right, then 1 minus 1 plus, what is our rate there? 12%, that's 0.12. Add that to 1. Please add that to 1. I wouldn't want anybody to ask me how I got 1.12 again. Add that to 1, you have 1.12. How many periods? Number of years, 10, -10. Okay, then I'm dividing that by my interest, which is what in this case, the same 0.12. Okay, here I needed to add it to 1. Here I'm not adding to 1. Then I seal up this bracket here. All right, so let's input this into our calculators. Is anybody helping us out? What do we want to do here? So you want to start from what is inside the bracket. Okay, so you could go open bracket 1.12, close your bracket, raise it to the power of a -10. What does that give you? This value. So you say 1 minus answer, you get that value, then you say answer, in this case, divided by 0.12, you get this. Then this one now you multiply by, you have 1,000,000 there. 1, 2, 3, 4, 5, 6. And what does that give you? Can somebody please confirm this answer for me? Are
Yes,
we good to
yes,
go?
yes, yes.
Okay, so that is 5650,223.03. So this is the present value that you should pay to receive 1 million naira monthly for the next 10 years. Okay, so let's go back into here and see what we got all the way, and voila, this is it. Now that is just example number 12 quickly. Let's have another person read it for us. Let's go. Example 12.
Find the future value of an annuity if 3,000 naira deposited into an account each year for 4 years, if the account pays 7.3% compounded annually.
Compounded annually. Now look at this. Find the future value. That is clear. We're finding future value here of an annuity. In fact, they might not even tell you of an annuity. Just tell you of 3,000 naira paid into an account each year for 4 years. That explains an annuity. And then the account pays 7.3% compounded annually. Now we're not told whether it is paid at the beginning or the end of the year. If such info, if they are silent on such info, it is assumed to be at the end of the year. If it were to be at the beginning, we will be told. Are we good? So well, what do we do? Let's delve into our worksheet again. Now we want to find what? Future value. What is this? You already know it's an ordinary annuity because nothing tells us that the payment was made at the beginning of the period. What is the formula? Again, we know there's an amount here. We have a bracket and we are dividing by R. Okay? But since it's future value now, go back to your basic future value formula. We know that is what? PV multiplied by 1 plus R to the power of N. There is no trigger here. There's no minus in the power. So what does that mean? Everything here comes first. 1 plus R to the power of N before your minus 1. That's the difference between these two formulas. I don't want you coming formulas and then you come back and confuses you. All right. So now that we have settled this, what then is the future value of our ordinary annuity? How much is being paid every year? We were told is sorry, the plane is flying back. We're getting the noise. 3,000. Then what's the rate? The rate is 7.3%. Now 7.3% is 0.073. Add that to 1, you get 1.073. I hope that is clear, please. Or who doesn't understand? Then N in this case, please speak up. I can't hear you.
Okay, I actually want to say, could you please look up?
From where? Do I start from here?
Yes, from the example to your calculate. Yes.
Okay, so you understand how we derive the formula, right? talk to me. Do you understand how we derive the formula?
You can please start from there as well.
Okay, so you're looking for future value of ordinary annuity. We already said that for both present value and future value, there are some constants. What are those constants? You have an A, and then you have a bracket, and inside the bracket, you have an R being your denominator. What causes confusion is what stays in the numerator bit here. So how do you get the right bit? Recall your basic future value formula, which is PV into 1 plus R raised to power N. Because there's no minus, you know everything I circled here comes here first. Then you put your -1. But when you recall your basic present value formula, you notice that there's a -1 here. That's a trigger that will help you to know that minus should come before everything here, including the minus, then 1 in its front. That's the difference between the two of them. But in this case, you're looking for future value. So that's that about that. Now I'm beginning to impute the numerical values. The amount to come in yearly, in this case, is 3,000 from the question we just read. The rate is what? 7.3%. And 7.3% is the same thing as 0.073. Add that to 1 here, you have 1.073. Raised to the power of 4, the number of periods or years in this case. I hope that's clear now. Then you have -1 divided by your R, which is still the same as 0.073. Then you close your bracket. I hope this is clear now, madam.
Yeah, it is. Thank you.
All right. So now that we have this, can I leave this to you? Input this into your calculator quickly and tell me your answer. Let's go. Fastest finger first. Can I even do it one at a go? I'm waiting. Are you guys doing it or you're waiting for me?
Me, I'm waiting for you, per se, because I tried downloading this calculator on so I couldn't get it. So I sometimes use my phone calculation, but it's not always giving me the exact thing as yours.
First off, thank you for saying the truth. I love sincere people. You should be the Nigerian Minister for Finance. We need truthful people there. So, and then secondly, you need to find something you need to resolve the issue as quickly as possible because you're going to be using your calculator in the exams. So it's the earlier you get, the earlier you started getting familiar with it, the better for you. So please work on that. So those of you who are doing this, are we on the same page?
Yes.
So that gives us a sum of how much? 13,379. 13,379.12. All right. So that's the future value of our ordinary annuity. So that's the formula being evolved there, 13 blah blah blah. Now that leads us to the second bit. Remember how I said here that annuity, ordinary annuity payment at the end of the first period. Annuity due payment at the beginning of the first period. Now you're going to see the differences now. So we move on to annuity due. For annuity due, cash flows are at the beginning of the period. For example, in many lease agreements, the first payment is due immediately, and each successive payment must be made at the beginning of the period. So anytime you see a lease, know it's an annuity due. The present and future values of annuity are given below. Now see, can you see formula now? All right. And I see why this approach I have employed would really help you a great deal. Okay, so we could have had to learn 6 different formulae: the basic PV and FV formulae, the formulae for ordinary annuity and annuity, present value of ordinary annuity, future value of ordinary annuity, and then present value of annuity due and future value of annuity due. So are the 6 formulae you could have had to learn. But what is the difference now? You are just going to adapt this what's it called, ordinary annuity formula a bit by just introducing 1 plus R for the same thing you have done here. Okay, so I'm just introducing this formula that we got here, So for the annuity due, you just open another bracket, 1 plus R. In both cases, present value and future value, and you'll be fine. So that's that about that. So there you have it. You can see it here. Again, remember your basic present value formula and the future value formula, and how that helps you to get your ordinary annuity formula. And then for the annuity due, just put another 1 plus R for both cases. I hope that is clear. Please, feedback. Is that clear?
So these two, PV and FV, are for annuity due, right?
They all have PV and FV. Ordinary annuity has its PV and FV. That's what we have just considered. And now we want to look at present value and future value of annuity due.
Okay, sir.
Okay. All right, so let's go. Somebody help us. The last speaker, help us with the example number 12. Let's go. Read for us.
Suppose you are considering a financial asset that promises to pay 1 million per year for the next 10 years, with first payment beginning now. The required rate of return is 12% per annum. How much should you pay for this asset?
What jumps right at you? What is the new thing that jumps right at you when reading out this question?
Payment begins now.
Beautiful. So that tells you it is what? Ordinary annuity or annuity due?
Annuity due.
Annuity due.
Annuity due. That is just it. Or a lease beginning now before you even start usage. Okay, so what do we do? Pick up your values. 1 million per year, you know, that's your amount. At times it could be PMT, payment. Next 10 years, you know, that's your N. Rate of return 12%, you know, that's your R. How much do you pay for the asset? Is this future value or present value?
It's a present value.
Good, because how much should you pay for it? You want to pay now. So having all this at the back of our mind, I go to the worksheet, and then we go. So we know this is present value of annuity due. Again, I don't know the formula. So what do? I start with the constant amount to be paid. I have this, right? For both future value and all. I know my basic present value formula, and I know it has a raised to power minus n. So I know that will come in here. All those bits will come in here, raised to power minus n. Then I know there's going to be a 1 in front. If there's no minus n, then it means this will come here and 1 will be on the other side. Now, because it is annuity due, what do? I introduce a 1 plus r. Is this clear to us?
Yes, let's go.
All right, so imputing values now. I know I have 1 million that is coming in yearly. Is it 6 zeros? Yeah. I open this. My rate is 0.12. I have 1 minus 1.12 raised to power. What's the period? 10 years. This would have been for ordinary annuity, but because it's annuity due, I'm going to introduce a 1.12 here, which is the addition of 1 plus r. All right. So again, input this into your calculator and give it to me. What do you get? I don't want to do this. Let me just write out the answer so as to save time. Okay, so you have 6,328 249.79. Okay, so confirm this, please. That's the answer anyway. So let's try and save time by moving on to something else. Okay, so okay, we won't see the answer here. There. That's it. All right, so let's go. Example 13. Somebody else, example number 13, read for us, please. Please read for us.
Value of monthly rental payments of 3,000 naira for 4 years at a required rate of return of 7.3%.
Future value stated already. Monthly rental payment 3,000 for 4 years. Okay. at a required rate of return of 7.3%. Again, 7.3% is 0.073. Don't make the mistake of doing 0.73. This is 73%. Please, if you please talk. Kemi, you are raising your hand. Please talk, please. I'm not. You're lucky I even looked now.
Okay, I'm so sorry to like take us back, but all of us were in the last class, the class that we just finished before this one, and we did almost the same thing or practically the same thing. But this very last question that you solved, this is your formula for present value of an annuity due. This last class, we were given a completely different formula.
Good. I saw your teacher. But by that you mean the class you just completed, right? Before I came on board.
Yes.
They are not completely different formulae. No, they are probably it is just the lettering that's different. They all represent the same thing. You can double
Yes,
check.
I think I just understood something now.
PMT.
This lecturer, like in this quantitative, the lecturer is differentiating between the present value that we can use both present and future value for annuity, ordinary annuity and the due one. You understand? So for PV and FV, ordinary annuity has its own. Then for due annuity due, it has its own PV and
Beautiful.
I
FV
FV.
understand
as well.
this, but like, I just want to confirm: will both formulas give us the same answer, or should we be differentiating that if we are doing QT, we should use this formula? And
Yeah,
if
the same
Same
thing.
thing.
They
Same
are the
thing.
same thing. It's just the lettering, probably. And that's why I was telling you, probably you was using PMT when
we
I'm
did
using A.
PMT, we had PMT plus PMT, we are doing -1 from the end. It looks entirely different to me.
You are doing -1 from N, right?
Yes, and
You
Yes,
know
we
what
did
you will do?
plus
You know
PMT.
what you will do? After the end of the class, sit down, use this formula you've learned here to solve his own question. You'll be amazed you get the same thing. All right. Again, my own idea is I don't want you cramming loads of formulas that can confuse you. They are all the same thing. Are we good? Anyway, let's just continue. You go do the research and then you give me feedback on the group afterwards. So example 13. Yeah, so let's go to the worksheet. So what is example 13 asking us for? Future. Okay, let me not go that far. So now this is future value, annuity due. What are the constants again? There's an amount coming in. I know I have to open a bracket. The R is here down here. But because it's annuity due, I'm putting 1 plus R. This is the confusing part. Now for future value, I know that I have a 1 plus R. This is a compounding factor. There's no minus up here. Because of that, all of this is coming forward. Then I have a -1. That is how it's different. What's going on? That's how it's different from what is it called? A present value formula. So here we are. Just slot in all the values and we should be fine. You have 3,000. I open my bracket. Here I'm having 1 point. What is the discount factor? 0.73 raised to power what? 4, the period, then -1 over R is 0.073. Please take note of this. Don't go and write 1.073 here or 0.073 here. There's a 1 being added here while it isn't added here. Then you put this, then you have your 1.073 again. Input all of this into your calculator at your leisure, on your speed. What do you get? 14,35579. Okay, 14,35579. Are we good? Feedback, please. Is my network still on? Feedback or Edakun?
Mr. Salako, we are trying to also be on the same speed.
I don't get. Are you are you inputting it in your calculator, or you are not getting me?
We're
You are not on.
inputting our calculator, so we want to be sure that
Oh, wow. This is a trade-off. I am trying to conserve time so that you can cover more ground, and you want to be sure that I'm not doing abracadabra for you. Or rather, you want to get used to your calculator. It's fine.
No, please, you can go ahead. Please, you can go ahead.
Okay, so moving on. That is also example 14. Any questions so far based on what we have done thus far? No question. So example 14
Quick
quickly.
question, sir.
Okay, I'm with you.
Okay, so I want to take us back to almost the beginning of the class, ordinary annuity. So you derived time, rate, and principal from simple interest, PRT over 100.
Yes.
And for time, you did 100 I over PR. So I want to know, is SI also the same as I?
Yes. That's why I cancel the S first.
Oh, okay.
I cancel the S first so as to make it clean before I continue.
Okay. Thank you.
You're welcome. All right, so we are on example 14 now. The person who asked the last question on simple interest, can you just read for us example 14? Are you there? Anybody else?
An 8-year annuity due has a future value of 1 million naira. If the interest rate is 5%, what is the amount each annuity payment of each annuity payment?
Good. In fact, it was a good thing the last speaker asked the question he did. Because the last question he did was paying attention on how to make something the subject of the formula. When he said I is P out over 100, then what is T? How did I get it? Okay, by now we should be used to that. Now the same principle is applying here. Now we are not looking for the future value. We want to get the amount. Okay, so what are the things we need to figure out? 8-year annuity due. We know it's annuity due formula. Okay, we're putting an extra 1 plus R. Future value given. Interest rate given. What is the amount of each annuity payment? So we know this is future value of annuity due. So let's go into that and state our formula. Future value of annuity due is given by what formula? What are my constants? There's a regular payment. I open my bracket. I know I'm dividing by R. I close the bracket here. And because it's annuity due, I am introducing 1 plus R. All right, so future value basic formula doesn't take a minus n. So because of that, I am putting 1 plus R to the power of n here before minus 1. Settled. Okay, now what were the things we were given? We were given the future value, isn't it? Or let me go this way. N, 8 years. We were given the future value as how much? 1 million. And then we were given the required rate of return as what? 5%. Okay, so slot in what you are given into this formula and you will be fine. Okay, so let's go. That means 1 million is equal to, we don't know what the amount is. So we go 1.05 raised to power n 8, then minus 1 over 0.05. Close your bracket. Then here you have 1.05. I hope it's clear up until this point, guys. Feedback.
Yes. Please, okay.
All right, so moving on, I have my 1 million here still. I have A. Now I need to simplify all of this and see what it gives me. So can we just do that together quickly? How do I proceed? Let me open a bracket, put this, then open yet another bracket, 1.05. I close the bracket, raise it to the power of 8. Press this sign, then I have a minus 1. Then I come down and put 0.05. Move out a bit. Close this bracket. Open another one. 1.05 close the bracket, then what does that give me? All right, 10.02656. So I can just simplify that to be 10.0266. Now, at this point, I want to make A the subject of the formula. What do I do? Suggestions? Anybody? What do I do?
Divide by 10.0266.
Bravo. Divide both sides by this value. And it's always nice you keep your decimals to at least 4 decimal places for your CIS. If you are doing CFA, they will advise you leave it to about 6 decimal places and then round off to whatever the question requires of you in your final answer. So please just take note of that. Okay, so 4 decimal places is fine. So when we do this, this will take this off. Eventually, your A will give you a value of let me go and answer. 99,735.06. Please, you can press that for me. 99,735.06. Please confirm. Just press this quickly so you can move on.
Correct.
All right, confirm it is. So back into the question. There we have it. So present value of perpetual cash flows. When we say perpetual, that's somebody's name, by the way. Perpetual and work water. So when we say perpetual, perpetuity, it reminds me of the infinity logo of our dear president, Bola Ahmed Tinubu. Yeah, the man of the moment. I hope you are not Peter Obi fans here this afternoon. Don't mind me, let's go on. So when we say perpetuity, it means the thing continues indefinitely. It is not expected to stop in the nearest future. Okay, so that is that about that. Can we have somebody read for us, please? From here, perpetuity. Anybody?
Perpetuity is a perpetual annuity or a set of level, never-ending sequential cash flows, with first cash flow occurring one period from now. The present value of a perpetual annuity is given below. PV is equal to A over R, where PV is equal to present value, R is equal to interest rate, A equal to initial cash flow.
Example 15, go on.
Okay. Example 15, present value of a perpetual cash flow of 100,000, giving an interest rate of 12%.
Great. So based on that, you know what perpetuity means. So here you are seeing perpetual cash flow, never-ending cash flow. What is its present value? All you need to do is take the amount that is expected to come in, how much? 100K, and divide it by the required rate of return or the interest rate, which is what? 12%, 0.12. What does that give you? Input into your calculator quickly, tell me. Are you there?
833.333.
Yeah, so
83333.
333.33. Okay. So you're having time value of money applications. All right. Most of the problems from time value matter are likely to ask for the present value or the future value, and we provide the other variables. However, in the exam, the examiner may look for unique and creative methods to test command of the material. A problem might provide both future value and present value and then ask you to solve for an unknown variable, either the interest rate, the number of periods, or the amount of the annuity. This is what we call change of subject or formula. By now, you should be well versed with that. Okay, so that leads us to the next subtopic there. Let's have somebody read for us, please. Annualized growth rate. Let's go.
Annualized growth rate, taking the formula for FV of a single sum of money and solving for R produces a formula that can also be viewed as the growth rate at which the sum of money grew from PV to FV in n periods.
Okay, example 16.
Example, the company's earnings were 100 million naira 5 years ago and are 200 million naira today. Find the annualized 5-year growth rate.
What is it asking you for? Change your subject of formula. Yes, anybody wants to hazard a guess? Okay, let's go. A company's earnings were this 5 years ago. What can we tag this? 100 million 5 years ago. What can we tag this? Present value. And 2 on today, future value. Okay, this is a bit. Okay, so this is it. I hope you can still listen to me, guys. I hope you can still hear me, rather. We have a timeline.
Yes, we can hear you.
Good. We have a timeline. Based on what we have here, 100 million will be considered our present value. Okay. And then 200 million will be considered our future value. We have a 5-year period in between. Now, what is the growth rate? Okay, so based on that, how does this thing go off? I don't have space to work. Okay, let me just use this place there. So, I really need a blank sheet. How do I hide this thing?
I think the pencil is highlighted. Maybe you have to unhighlight it.
Still is not going on. I think it's hide video panel. It's not even hiding still. Oh. Let's just manage it this way, please. So where were we? There. Okay, a company's earnings 100 million today or 5 years ago, 200 million today. So we can say 5 years ago is our present value, and then 200 or today rather is our future value. So as to be able to solve what we need to solve. So why do we need to make such assumptions? All right, so let's just work with the formula rather. So we know that what is it again? Future value. Let's have a future value or present value. Okay, so we know that future value is what? Present value into 1 plus r raised to power n. Now let's do a bit of change of subject of formula. Remember, the question is asking us for the annualized growth rate. That means we want to make r stand alone. We want to isolate r. So what is the first thing we need to do here? This is a PV times this. So you divide both sides by PV. I hope you are following. This takes this off. Then I'm going to be left with future value over present value is equal to 1 plus r to the power of n. I think we did this a couple of classes back. Now I need to take this raised to power n to the other side. How do I do that? I simply need to multiply both sides by 1 over n, the power of 1 over n. So this takes this off, and this is what is going to be on this side. So it becomes, do I need to write this again? Okay, let me just do so to avoid some questions. 1 over n is equal to, now this becomes 1 plus r. All right, now I want to make r stand alone. I just need to take this 1, which has a plus sign here, and bring it to the other side. So it becomes future value over present value raised to power 1 over n. Then that plus 1 comes as a minus 1 is equal to r. I hope this is clear, please.
Sorry, no.
Yes, we have it in our previous this thing.
Yes.
Okay. Okay. Who said no? Can we continue or I should go over that again?
Please, I do not understand.
That means you have not watched the previous videos.
Yes, please.
So you know what you'll do for me because of time? Let me continue, but you go watch the previous videos. If you still do not understand, reach out to me on WhatsApp. Is that fine by you?
Okay, sir.
All right, so let's go on. So the future value from the question is 200 million. Permit me to just write 200 because the present value is 100. Okay, so all those zeros have cancelled out. Raised to power 1 over, what is our n? We're told it's a 5-year period, then minus 1 as a whole number. That will give me my R value. So what is the R value? So 2 divided by 1 is 2. I can just do that here. Open a bracket. There's no need to even open a bracket. I'll just say 2 to the power of 1 over 5. Right? Yeah. So that gives me this value. Then I do a minus 1. And that gives me that value. Okay, so R is equal to 0.1487. Multiply this by 100, you have 14.87%. Either way, you are good to go. All right, I hope this is big enough. I hope you can see the text and the workings as well. Can I get a feedback?
Sir, yeah, I can see that, but the only thing that is confusing me at this point is how we made 100 million our present value and 200 million our future value.
Okay, I explained that earlier. So the point is always a case of start. How much are you starting with and how much are you ending with? Do you get it now? Because if you want to look at it from the perspective of now and 5 years ago, mathematically, we don't actually have that 5 years ago bit, no. So what we do is to adjust it in the sense of how much did we start with? How much are we ending with? How much you are starting with is your present value. How much you are ending with is your what? Future value. So look at the question. A company's earning was 100,000 naira 5 years ago. You can even put it this way. Okay, so this is now. This is now here. I don't know why this is coming. This is now. Okay. So if this is now, how much are we getting now? 200,000. So now in relation to what? Is it now in relation to the future or now in relation to the past? This question says now in relation to the past. So if you are doing now in relation to the past, logically speaking, what should be our present value? Will it be this 100,000 will refer to which amount you are getting? Is it the value you are getting now or we got 5 years ago? This is the value we got 5 years ago. So logically speaking, this should be our present value for 5 years ago. And what we are getting now will logically be the amount for the future value. Does that make a bit of sense to you?
Yes, please. Thank
So
you.
based on that, we can now move on and resolve. Okay, so we're done. We got this value, and that leads us to another concept here: net present value and the internal rate of return. Net present value and the internal rate of return. Now, these are huge concepts on their own. Okay, so what I want to do at this point is probably call it a day, and then we continue from there in the next class. Okay, yeah, these are new concepts. I'm going to be doing a whole lot of this. Again, building on what we have learned thus far. See them. So I'm going to stop the video now. I'm going to stop recording. And again, I want to urge you, if you have not watched the... Stop recording.